Now in this video we're going to determine models again, but this time of logarithmic models. We learned at the start of the last video that if a graph has a horizontal asymptote, you've got to have an exponential function. This time we have a vertical asymptote, so straight away that's our clue that we have a logarithmic function. So because it's logarithmic, we're going to be using this general form. Y is equal to something, some a value multiplied by the natural log of x plus b plus c. Now you remember from grade 11, whenever you've got a function, you've got a bracket with x added to something inside a bracket, that shifts your graph left and right. It doesn't change here, it's still going to be exactly the same. All logarithmic models are asymptotic to the vertical axis, unless they've been shifted. This one's been shifted. Now, on the previous video when we did exponentials, the first thing we went to was the asymptote. Same thing here. First thing we go to will be the asymptote. So number one, the asymptote. The graph doesn't exist at the asymptote. It never actually reaches. It gets closer and closer to the x value of -1. So we know that the graph will not exist at x equals -1. If I rearrange that to be x plus 1 is equal to 0, we know that the log of 0 can't be done. There is no answer to the log of 0. So that must be a bracket. If I make the bracket x plus 1, I'm taking the log of 0, therefore the graph doesn't exist. So therefore I now know that my b value must be equal to 1. So far I now have the graph in the form a times log x plus 1 plus c. Priority 1, asymptote first. Now, our second port of call is, in our exponentials, we went to where the x value was 0, was our next port of call. It's not that clear cut in logs. But we are going to use a concept that you already know and understand quite well to work out which one of these 2 points you go to next. Sometimes you'll go to this information, sometimes you'll go to that. It all depends. And it actually depends upon what you have in the bracket. Now, when we did this step here, we worked out the idea that taking the log of 0 doesn't exist, hence the asymptote. We're now going to use another principle, and the principle is that the log of 1 produces an answer that we know. So if we can make the contents of our bracket equal to 1, when I take the log of it, I'll get this known value. So I want the contents of my bracket. So I'm going to look for where the contents of my bracket is equal to 1. So what x value do I need to make the contents of my bracket equal to 1? Well, in this situation I'm going to need an x value of 0. Do I have a situation here where I have an x value of 0? Yes, I do. This particular point here. It won't always be that. The contents of your bracket is going to change question by question. You're not always going to go to the y-axis first. You may have to use the other point. You might get questions where you have information contained somewhere along the curve. But for step number 2, you are looking for the contents of your bracket being equal to 1. What x value is needed to do that? So I'm now going to use this point, which is the point 0, 1. So therefore, y, my y value is 1, is equal to a times the natural log of x plus 1. So x value is 0 plus c. 0 plus 1 is 1, natural log of 1 is 0, 0 times a is 0, I can get rid of that. So 0 times a is going to be 0, plus c, I now therefore know that c must be equal to positive 1. So therefore my equation is currently y is equal to a log x plus 1 plus 1. So I've got 2 bits of information found. I can now go and use my third bit of information. And that third bit will be use the last point that I've got. Now, that's the x coordinate where it cuts the axis. So the point is e to -1 minus 1. That's the x coordinate, cutting the x-axis, so the y coordinate is 0. Substitute that in, y is 0, a times the natural log of x is e to the negative 1, take 1, plus 1, outside the bracket, plus 1. Oh, it looks messy, but let's break it down. So inside the bracket, negative 1 plus 1 is 0. I'm just left with e to the negative 1, and then I have my plus 1 on the end. Now, the natural log of e to the negative 1, the base of the power is e, the base of the log is e, the answer must be negative 1. So that's a times this, gives me a times negative 1. This over here, this plus 1 on the right, I'm going to make it negative 1 on the left. So therefore, a must be positive 1. I now have my 3 bits of information, so therefore my function is going to be y is equal to a, which is 1. So 1 lot of the natural log of x plus my b value plus my c value. And there's using logarithmic models to represent what's happening here.